So we have actually soon the two operations. One is heap deletion and another with replacement of all those nodes on the heap. So now the third operation that we want to do is the also delete the root node from the heap. So we'll discuss coding now. Okay. So actually the root node will be deleted. So after deletion, and so how to make it a heap after deletion? Then instead of root element or including, I will exclude the root element and the remaining elements would construct a heap. You don't need to construct the heap element for those remaining elements. Um, to we will the node for which for the last node index will be interchanged with the root node, and the root that at that position, the last for position will include a non-character so that the root node is completely deleted. Now the remaining elements will be used to construct a bit. So the root node has gone to the last index, and now last index after that it has been deleted. So because it is converted to null character, and the watch node was at the last element that was found to the root position. Now now the entire structure cannot really, because the last element which has come to the root position may be such that it is less than its should one. So there is the checking of whether it is greater than or less than of its should one or not. If it is less than should one, then it will move downwards. So for variation operation also, we need to do the downward movement. So it is just like the similar of replacement 14, but difference is that in replacement the array size, the serial array size before replacement and the after array size after replacement array size is remain same. But when the node root node is deleted, then after deletion the size of the heap become, the number of elements in that heap after deletion will be one less. So size of the heap differs. That is the only difference between deletion and replacement. So we will start to write the code for the deletion. Now we have already, if I just open the program editor, for cd program and cd option then gedit keep operation dot c. Okay. So if I go to the main function, then we can see that in the main function, the actual operation is done by this port, which is within a do window. And here we can see that if I want to insert a new node into it, then we have to give the option 1. If I want to replace it, then we have to enter 2, and for deletion, we have now we will include that enter 3 to delete from the heap. Enter 3 to delete root from heap. Otherwise, if I enter any other values than 1, 2, 3, other than 1, 2, 3, then that will terminate program. So here also I need to include that choice that else if choice equals to 3, choice equals to 3, then the operation will be delete operation will be performed. Now delete operation will be performed by this delete function. Now we have to write the function body of this delete. So first we declare the function void delete, and after that we have to define the function body. We have to define the function body. So first of all, we have to check how many elements are there in the heap. How many elements are there in the heap? If the heap is empty, then we cannot, deletion operation cannot be performed. So for that, I have to choose the array size. How to check the array size? For that, I have to access each of the array position, and if it contains a null character, then we will stop that position. That means array. After that, all the array elements are null characters, so we will not go further. And from there, I can get the index of the last element, index of the last element, which is included in the heap. So to access each position of the array, we are using a for loop. So I equals to 0, and maximum size, I should release the maximum size of the array, which is I is less than array size, then I plus plus. Next it will check if array I equals to a null character. If array I equals to null character, so let's see one thing. If there is only one element, so array I will start from one index, because 0th index array element, 0th index array element is result. That is how something have arbitrarily given a number. So if array I is not is array I, if I can say one thing, if array I is not equals to null character, so in that case I will initialize a variable in last index. In last index was to 0. So if array I means first position array 1 is not equals to null, then we will increment the null variable last index by 1. But when it becomes, suppose at some point, at some index of the array, it becomes a null character. So in that case, I will come out from the loop using break. Okay. So now after coming out from the for loop, when the control comes here, now we have to see whether array is empty or array is not empty. How can I say if the last index is 0, that means array is empty, so in that case you cannot get it. So if last index supposed to 0, so in that case, last index is greater than 0. That means there is element, so we can do the deletion operation. Otherwise, if the last index is not greater than 0, else just print the for only one line will be written, so don't have to get the 7 lookups. So print here into use versions. If it's empty, so those cannot be deleted. If it's empty, those root cannot be deleted. This message will be displayed if it becomes empty. Otherwise, it will go on to perform the deletion operation. For deletion operation, we will replace the root node. We will replace the root node by the last node. Last node, what is the index of the last node? It is stored in the variable last index. So we will So at the position of array 1, the element array last index 24. Now the root last element has come to root position, and we have not solved the previous row for anywhere, so it is now lost. But now the the array size also decremented by 1, and what I have to do, I have to place a null character at the last index position to indicate that array size also decremented by 1. So I'm placing a null character but the previous last element was stored. Now last elements have become the root node, but which can be less than element, so I have to check that. So how to check that whether it is no, it is less than its children or not. For that I need to get the value of the children. So there are two children. One is child 1 and another is child 2. And I had to check whether child 1 has value greater than child 2 or child 2 has value greater than child 1. Then depending on that which has a greater value, that will be stored in this variable next child. So here I will check. And suppose if the last index, if the there was only one element, there was one element that is only root node. After deletion, it becomes empty. After deletion, it becomes empty. So I have to so in that case, the last value of the last index will be 1. So I have to do only I have to interchange only when they interchange the root element with its children when there is a child. How to check whether there is a child or not. So for that, I will find out the index of child 1, which is 2, and which is 2, and the child 2 will be 3. So if last index, so if last index is greater than 1, that means we have not deleted the root node. There are children on the root node also. So last index will be greater than 1. If that is the case, then we will do the comparison. What comparison? If array if array 2 is greater than array 3. If array 2 is greater than array 3, then child connects will be 2. Otherwise, child connects will be equals to 3. And the last index is greater than 1. Now, so now I will check whether the root node has base value or greater value than the child node. If the root node documents array 1 as the base value, then array child means then array child means then. So one thing is if everyone is short, then down note down this function will be used. That's well. No, in this case, I think if last index is greater than 1, then only this note down function will be called note down. And which node do we note down? Note down 1. So this node will be of down 1. So, and here another thing is if I recapitulate the note down function, here the parent value is passed, then child 1 and child 2 gets generated, then it checks the last element of the array. If the child 1, then last index child 2, then swap, and then swapping will be done. And then there is a recursive maintainable. So only we have to route here if the last index is greater than 1. So then we will follow the maintain function with, with the current position on the photo. Current solution of the function, which should be compared with the achievement. That is maintain 1. And on the current node is 1, which will be choose with its children. So that's why maintain 1 we want first it. Now, before downwards movement, I will print the array, and after movement also we will print the array. So for that, then during insert also. So we can go to this I got use the function of like this use the function. So here I will think the array will choose onto the other virtuals functions, that is after before that is array after deletion, array after deletion, then the function print array will be called, and when it is moved down, if last index is greater than 1, then it is moved down, and again I will print the array. Okay. So until I will we put them touch control V array. It now it is not the array, it is a active deletion, and printer will print what. So that program has been written. The program has been written. Now I'll compile the program and the next video. Okay.